All right, welcome to this lesson, and this is the first video on continuity because we have concluded our question on limit with the question as n approaches infinity of 1 plus 1 over n all to the power of n. So this will be our first question on continuity. So the idea about continuity is that when is a function continuous? A function is continuous if all the line of the graph can be traced. If that is you can play around the graph without stopping or skipping any value. Example is this, like this is your graph now. This is your graph. All the points you acquired, you can keep your hand like this and trace all of them without stopping. That is actually continuity. All the points around or up to 2, is it continuous? Or is this function continuous around the neighborhood or at 2? Let's find out. Now the question is this: when is a function continuous? When is a function continuous? Now, a function continuous, if a function is continuous around that value or at that value, if the function is defined at the value. Now, I'm going to assume these two to be equal to whatever variable I like. In this, mostly a is used. A. Now for this to be continuous, f of a, these are the conditions. The first condition says that f of a must be defined. That is, f of a must exist, must be defined around this boundary. 2. The limit as x approaches a of f of x must exist. The limit must exist. And the last property is that the limit as x approaches a of f of x, this number 2 must be equal to f of a. If all these three conditions are met, then we can say this function is continuous. Now let's test the first one. The first one says that f of a must be defined, and we know that we have already set these two to be a. So now let's see f of a. Now f of a is equal to f of 2, which is equal to 3 into 2 plus 5. 3 times 2 is 6. 6 plus 5 is equal to 11. Now that is the first condition. It is defined because it gives us a good answer. So 2 is that the limit must exist. Now this is a simple polynomial equation, and the limit is always simple to find. So limit of f of x as x approaches 2 is equal to 3 into 2 plus 5. That is 3 times 2, 6 plus 5 is 11. The limit exists. Yes, the limit exists. Okay. So now the third one says that these two limits must be equal. Are they equal? Yes. So the limit of f of s as x approaches 2 is equal to f of a. So by this, we can say that this function is continuous, and most times the limit must exist from both the right and the left. That is the condition here. The limit here must exist. That is, the limit as s approaches a from the left of f of x must be equal the limit as x approaches a from the right of f of x. These are the two conditions. And here you will see why did you do that. Now if you pick s as 2, as put this is our number line here, these are 2 here. To the right of 2 you have 2.0 to the left you have 1.999. If you put any of these two values into x here, you still get 11. So So this is it, and see you in the next video. This is the idea behind limit, so you'll be earn continuity. So thank you, and see you in the next lesson.